Good morning, everyone. Today's video is on solving one-step equations. This should be in your salmon colored packet. So this is page 2, the back of the cover. So we're just gonna start with kind of refreshing our memory with a couple vocab words that we've talked about many times this school year, but we're gonna bring it up again because we're gonna keep using them over and over. So the first is coefficient. The coefficient is the number being multiplied by the variable. Okay, it's the number attached to the variable that's being multiplied. The constant then is the number by itself. Okay, remember the value never changes. Okay, it's the number by itself. Opposite operations. So we should know these. The opposite of addition is subtraction. I'm just going to put a subtraction sign. The opposite of subtraction is addition. Multiplication would be division, even though I hate that little sign. And the opposite of division is multiplication. Okay, so this is important because we're going to be using opposite operations all the time when we're solving our equations. So whenever we solve equations, does not matter how short or long the equation is, does not matter. The goal is always the same. The goal is to isolate the variable, okay? And the word isolate means to get the variable by itself, right? Like when you isolate something or someone, okay? You get it by itself. So our goal is to get the variable by itself. And in order to do that, we use opposite operations, which is why we just went over those. Okay? All right, so let's do some examples here. Okay, number 1. So I always draw these what I call train tracks around the sides of the equal sign. You do not have to do that. I have found that it does help some students like visually separate the two sides of the equation. So you can do it or you don't have to do it. It does not matter. So what you have here is x plus 5.5 equals negative 17.5. So if we're trying to get the x by itself, we have to get rid of this 5.5. And right now, the x and the 5.5 are being added. So we are going to do the opposite, which is subtract 5.5. Now, because this is an equation, whatever we do to one side, we have to do to the other side because we have to keep the equation balanced, okay? So we do this because positive 5.5 and negative 5.5 give us 0, right? That's that additive inverse property. When you take a number and you add its opposite, you get 0. So these are gone, and then all we have left is our x, which is what we wanted. We've isolated the x. So then negative 17.5 minus 5.5 is negative 23. Just be careful with that, okay? And again, you can use your calculator to help you with that. Now, what we're going to do on our check, okay? Our check is always the same kind of process. Step 1 is we rewrite the exact equation we were given. Okay, exactly as it was given to you. Step 2, we found x to be negative 23, so we plug negative 23 in for x. This is our substitution. Okay, we rewrite the rest of the equation exactly how it is, and now we just use PEMDAS to clean this up. So negative 23 plus 5.5 is going to give us that negative 17.5. Equals negative 17.5 because we just keep bringing this down and it checks. So now we know that we're good to go. Okay, I'm going to try to focus this again. Number 2, now we have, again, I'm going to do the train tracks. Okay, x minus 3.5. Well, the 3.5 is negative. Okay, so in order to get rid of that negative 3.5, we do the opposite, which is add 3.5. Again, whatever I do to one side, I have to do to the other side. Okay, negative 3.5 plus 3.5 is 0, so those go away. I'm left with just x, which is what I wanted because I've isolated my variable. And then negative 15 plus 3.5 gives us negative 11.5. And yes, you could have put negative 11.5, that's fine too. Okay? Check. Same thing. We start by writing the original equation, okay, exactly as it is. In place of x, we put negative 11 and a half. We bring down everything else exactly as it is. And then you can pick up your calculator to actually punch this in. Don't assume that you're correct, okay? Actually punch it in. Negative 11 and a half minus 3 and a half does give us negative 15, which equals negative 15, and it checks, okay? Number 3, again, I'm going to start with the train tracks. So now we have negative 3 being multiplied by x, okay? And we know that because there's nothing in between them, right? That negative 3 is that coefficient we talked about earlier. So to get rid of the negative 3, we're going to divide by negative 3. And we do that by using a fraction, okay? You're not using that little division symbol. You do this like a fraction. Remember, whatever we do on one side, we have to do to the other, okay? Negative 3 divided by negative 3 gives us 1x, which again is what we wanted. And then negative 18 divided by negative 3 is positive 6. So when we go to check, we rewrite the original equation. Now be careful because the negative 3 is being multiplied by the x. When I plug in that 6, I'm going to use parentheses to do so. Okay, so the negative 3 times 6 is negative 18, which equals negative 18, and it checks. Okay, and then number 4. So for number 4, right now the x is being divided by 3. So in order to do the inverse of that, instead of dividing by 3, we're going to multiply by 3, sorry. And I do that just like this. Okay, I put the 3 in parentheses kind of next to it like that. All right. So then multiplying and dividing by 3 cancel each other out. We're left with our x. Negative 7 times 3 is negative 21. Okay. So now again, we check. We have x divided by 3 equals negative 7. In place of x, we plug in negative 21. And negative 21 divided by 3 is negative 7, which equals negative 7, and it checks. Okay? All right, so that is your notes on one-step equations. You're going to go ahead, I think, and try page 3, and that's going to be a separate video for that as I go over page 3. Okay? All right, everybody, thank you so much for watching. If you have any questions, you know how to get a hold of us. Bye-bye.